Hello and welcome back to my channel. So today we are going to start a new topic, that is derivatives of a function. So in the previous videos I was talking about limits. So in today's video we'll start about derivatives. So first let's understand the slope of a line. Before we go on to derivatives, let's understand the slope of a straight line. So here I have made a diagram, and this we can see AB is a straight line. There's a linear relationship here. So A is x1, y1, right? If I write the points, the point A is x1 and y1, and point B is x2, y2. Now the slope of a line means the change in y, y1, y2 with corresponding change in x. So that means we can write the slope as, so the slope can be written as change in y with respect to change in x. So in this case we have AB, and we need to find the change or the slope of AB, that is y2 minus y1 by x2 minus x1. So this gives us the slope or the steepness of this line. So this is the formula for a linear relationship. Now what happens if we have a curve and we need to find slope on that curve? Now as you can see, I made this diagram, and just by looking we can tell that slope is different at different points. I mean, here we have a little bit more steeper than this area, so there will be different slopes at each point. And even mathematically, let's apply the previous formula. Let's see how much different that is. So if we apply the slope formula for a linear relationship, let's say we take A and B, and we need to find the slope between A and B. So slope between A and B will be slope between A to B, right? So slope between A to B will be 1.5 minus 1, which is the y, 1.5 minus 1, and the x-axis we have 1 minus 0, that is 1. So 0.5 for A to B. Now what if we need to find the slope of B to C? Keep in mind that we are actually just checking the straight line between A and B. This is the slope. So let's find the slope between B to C. So slope B to C will be 2 minus 1.5 by 1 equals 0.5. Okay, this is similar. Then slope between C to D will be C to D is 3 minus 2 by 2.5 minus 2 equals 2. So we can see that the slope of C to D is different than slope of B to C. So what do we do in this case? So for a curve we just find a slope at a single point. So that is more accurate. So if we can find slope at different points, we can find the slope at B, at C and D, and all these will be different. So how to do that? Now the method to do that is by making a tangent at that point. We just draw a tangent to the point on the curve on which we have to find the slope. So if I want to find the slope of C, point C, then I just draw a tangent like this. like this. So this tangent is only touching the curve at point C. So if I find the slope of the tangent like I did before, I'll get the slope of point C. So I just have to put the values like just take any two points on this tangent and then find the values of y and x and get the slope, so that automatically I get the slope of point C on the curve. Now moving on to the derivatives. Now derivatives of a function is defined as the rate of change of function with respect to the independent variable. So I can write it, if I have a function like y equals f of x, now the derivative is defined as change in y, or derivative is change in y by change in x, okay, or change in the value of function. Now the derivative of, mathematically it's defined as, let's say derivative, let me just write the mathematical formula. It is given as limit h approaches to 0 function of a plus h minus function of a by h. So a is, so what it says is the derivative of the function at point A. So we know that it's a curve, so we have only a point. You have to find the slope on that point, or the derivative of the function at that point A in the domain. So here I have drawn a diagram. So we have 2 points P and Q, and P is corresponding to point A on the x-axis, and then value of the function is function of A, right? It can be any value, so we have just written function of A. And then for Q it lies A plus h, so that means it is h distance from A, so A plus h on the x-axis, and the function of value will change to function of A plus h. Now if we draw a straight line, if we use the previous formula for slope of a line, we can see that from distance from P to Q it is, let me write it here. So if I use the previous formula for the slope, I can write it as function of, this is the y part, function of A plus h minus function of A by h, right? Or we can just simply write A plus h minus A, so that will give us only h. So this will give us the slope of this line PQ, but here we need to find the slope of this function at point P, right here. So this is the point P, this is A f of A, and this point is A plus h function A plus h. So what do we do here? So mathematically, as you can see that here we have a limit. So why do we have a limit here? Limit means the h is approaching to 0. That means this PQ line is approaching P. So that means it is approaching a point P, so which is equal to the tangent, which is similar if you are taking a tangent at P, right? So if I'm applying a limit here, limit h approaches 0, that means the whole this slope or this line will approach P, is approaching a point. So we can write limit h approaches 0 function of A plus h minus function of A by h. This means that the line is approaching point P and we are getting the slope at point P, right, which is similar to the tangent. If we are making a tangent, or I can write it as it is equal to the slope of the tangent at point P, right? Now we can understand this is what the mathematical formula says. That's why we are applying limit here. So it is just equal to slope of the tangent at point P, which gives us the derivative of the function at point P, or we can say at A, because the value of the function at A. So this concludes this video. In the next video I shall solve some problems based on the derivatives. So thanks for watching.